Okay, now I was a little careless when I wrote this down. I just wrote down the A here, and then I realized, actually, I'm going to want A to stand for this matrix, and also we don't need A. Because if A is just a number, A times X is just a constant column vector, right? So we've got that covered with the X vector. We don't need an A here. That's like having an extra constant. We've already got the constants. Does that make sense?
Yeah.
So I can eliminate this A from my equation. And just in keeping with my general you see the A would have divided out anyway.
Right.
Okay? So it would have never appeared. So all I did was confuse the notation that I want to use. And that was just kind of careless. Okay, so again, we just don't use an A here. It's redundant, unnecessary, and confuses the notation that I want to use. Okay, so without the A, we get this. And if the A was there, it would have divided out anyhow, but yeah, we just get rid of it. Okay? So what we get then, the e to the lambda t divides out, right?
Right.
So we get
So you get lambdas. When the x is divided out.
now I'm going to confuse you because I'm going to use x here, right? I'm going to use A for this matrix. And having had it here, that can be a little confusing, so I do apologize, okay? But the A is going to stand for this matrix. So,
Let's just scrap this one for a second.
as before, this is going to come out looking exactly like the characteristic equation we'd have for second order equation with constant coefficients, okay? So we're doing exactly the same thing we did then, although you might have forgotten what we did then. We have this, right? So A minus lambda I times X is 0. So A minus lambda I is just 4 minus lambda, negative 2, 1, 1 minus lambda. And that multiplied by x equals 0. Okay, you only then have solutions for x if the determinant of this thing is 0. Okay, so you get that determinant has to be 0 in order to get a non-zero solution. For all the reasons that was the case with second order equations. Okay? Well, that means then your eigenvalue situation. Okay, we know how that works. So you get 4 minus lambda times 1 minus lambda plus 2 equals 0. That's what? Lambda squared, and you're going to get minus 5 lambda plus 4 equals 0, right? And that easily factors. You get lambda equals 1 or lambda equals 4. In general, you use the quadratic formula to solve this. But this one factors into lambda minus 4 times lambda minus 1, giving us this. Okay? Now, where do you go from there? Okay? Well, this means
Now can we do it? We just plug them back in like we used to with the.
if lambda equals 1, yeah, but it comes out a little bit different. Okay? If lambda equals 1, you get then y equals e to the t X. Okay? Meaning, of course, that okay? And where do you go from here?